Hey students, welcome to the combined gas law. Today we are actually going to combine what we know of both pressure or Boyle's law and Charles's law. So let's see what we've got by jumping right in. This is 6.4 combined gas law, page 38. So let's review. Remember Boyle's law was, screen's still moving, P1 V1 equals P2 V2. Those were our formula. That was our formula for Boyle's law. Now let's do the same thing for Charles's law, right? V1 over T1 equals V2 over T2, or we looked at it in terms of V1 T2 equals V2 T1. Now, if we just squish those together and kind of eliminated the extra V's there, right, we would come up with P1 V1 over T1 is equal to P2 V2 over T2, right? Or we could look at it in terms of P1 V1 T2 is equal to P2 V2 T1. Now, guess what? You don't have to memorize Boyle's law, because if something says the temperature is constant, you just lose the temperatures. If they say the volume is constant, we just lose the volumes, and then we don't have to worry about it. So this is the only one, for right now, that you have to memorize, and it's fairly simple. All right. Now, going back to the background, the STP, standard temperature and pressure. This is very, very important. It shows up a lot, standard temperature and pressure. So please star this in your notes. All right. We will see it frequently. All right. Standard temperature and pressure. So standard temperature is 0 degrees C, which is also 273.15 Kelvin, right? Then standard pressure is what we are at in the atmosphere, and that is 1 atm. But that equals all that plethora of other stuff, all those others that we have, 760 torr, 760 mmHg. So you can use any of those there. So the list just goes on and on. But a lot of your questions will be like, what happens when we move this to STP? So that's something that we need to look at. All right, so let's go ahead. Still our temperatures need to be in Kelvin. That has not changed. Let's look at an example here. We're just going to have a little bit more here to do. All right, so we have a 9-liter air sample. Well, hello, that's a volume. And we have a pressure. That's P1, Griffith, not 1. Okay, P1, and there's our first temperature, T1. If the temperature is raised to 107, so that's T2, and the volume expands V2, what's our new pressure? Ooh, and a little tricky, what's our new pressure in atmospheres? So we've got a little extra work to do, but we'll get there in just a second. So let's write this out. P1 is 117 kPa. V1, 9 liters. T2, remember, we want to put that there. T2 is 107 degrees Celsius, but we've got to add 273.15 to that to get us to Kelvin. Remember, our temps have to be in Kelvin. All right, we've got 380.15. P2 is what we're looking for, and it's an atmosphere, so we're going to have to do some work at the end, which is totally easy. We're fine. V2, our second volume, is 17.00 liters. And last but not least, T1, first temperature, is negative 25 degrees C, so we started pretty low. All right. And again, we have to add 273.15 to it to get us where we're at. And that answer should be 248.15. And so remember, our formula that we're going to use, P1 V1 T2 is equal to P2 V2 T1. And now we can just plug it all in and solve. We're going to double check and make sure our labels are all what they need to be, kPa, and we need to get it to ATM, but liters, K. All right, sweet. So let's go. We've got 117 times 9.00 times 380.15 is equal to our question mark, so we're just going to leave that P2 times 17 liters, and then times our temperature of 248.15. Okay, there we are. Now we need to isolate P2. So we're going to just divide each side by 17 times 248.15. Yes, we could have multiplied those together and got this, but this works too. I only like to pick up my calculator once and do the math, so you can call me lazy, you can call me whatever you want, but we're cool here. All right, so P2 is going to be equal to 117 times 9 times 380.15. Then we're going to divide by 17 times 248.15. And that's going to be our answer. That's going to be our answer in kilopascals. So we have to do a little bit of extra work, so we'll get there. 117 times 9 times 380.15 divided by 17 divided by 248.15. And our answer in kilopascals, remember, is 94.89 kPa. And we need to take this to ATM because it said it wanted the answer in ATM. So this is where we practice our pressure conversions. And we know that 101.325 kPa is equal to 1 ATM. I found that on the back of my periodic table, or maybe I just knew it, but either way, still works. So we're going to divide that number by 101.325, and our answer is going to be, keeping two decimals, 0.94 ATM. 0.94 ATM. And we are done. Kind of went in a little bit of a round, but we made it. Okay? Everybody good there? Awesome. Let's check this next one out. Okay? Gonna have to go with a different color since we're so close there. All right, let's start with orange here. All right, so a sample of gas. Ooh, there's T1 because it's a temperature. 1.03, there's a pressure. Occupies a volume, V1. What volume? We're looking for V in this one. And there's T2 and there's P2. All right, so let's plug it in and see what we've got. So P1 is equal to 1.03 ATM. V1, our first volume, is 2.20 liters. T2, remember, I'm already rearranging it so I don't have to worry about it. Ooh, and we gave us the same temperature so we didn't have to work too hard to find our Kelvin temperature. Hopefully it's the same as what we got above. Hopefully I did that right. P2, our second pressure, 0.789 ATM. Ooh, our ATMs match. That's awesome. V2 is our question mark. And T1, remember, is our 47 degrees Celsius. So that needs to add 273.15 to it. All right, and if you guys can hear the dog in the background, I promise it's not mine. All right. We get 320.15 K. So our Ks match, our atmospheres match, our volume will be in liters when we find it. So here's our formula, P1 V1 T2 equals to P2 V2 T1. So let's plug it all in. 1.03 times 2.20 times 380.15 is equal to 0.789 times V2 and times our first temperature, which is 320.15. All right. So again, we want to isolate there. So we're going to divide by 0.789 times 320.15, trying to get the V2 by itself. All right. I didn't mean to cross out the V2. Go back to that and try again. Okay. So each side is going to be divided by 0.789 times 320.15. So V2, if we write it out, 1.03 times 2.20 times 380.15 divided by 0.789 times 320.15. All right. So we've got 1.03 times 2.2 times 380.15 divided by 0.789 divided by 320. You ever feel like you typed it in wrong, so you went back and tried it again? Yeah, I did that. So we're going to divide that by 0.789 divided by 320.15 And our answer should be V2, 3.41 liters. Does that make sense in the whole scheme of things? Yeah, it does. All right. I'll see you next time.